for the 7th seminar in the Ciclo Observatorio Virtual, and I'll hand over to Enrique now to present our speaker today. So take it away, Enrique.
Thank you, Lee. Good morning, good afternoon, everybody. It's a real pleasure to have Miriam Cortés Conteras with us today. Miriam holds a degree in physics from Universidad.
Sorry, Enrique. Sorry to interrupt. You're coming through very quietly. I think it's up on the maximum at our end.
Can you hear me better now?
Perhaps if you can get the microphone a little closer, that would be perfect.
Yeah, and it's as close as possible, I think. I don't know. But
okay, that's a little better. So if you just maybe speak up a little bit, that would be perfect. Thanks, Enrique.
Okay. So thanks. So I was saying that it's a pleasure to have Miriam with us today. Miriam holds a degree in physics from Universidad de Salamanca and a PhD in astrophysics from Universidad Complutense de Madrid, where she is currently working as Profesora Ayudante Doctor in the group of cool stars and superstellar objects. Despite her teaching duties, Miriam manages to find some time to do science, mainly in the framework of the Carmenes project, in particular in the field of characterization of cool stars and type stars. And in addition to this, she is also interested in the scientific exploitation of astronomical archives using virtual observatory tools and services. And this is because before moving to Complutense, Miriam worked for 5 years at CAP in the Spanish Virtual Observatory Group, and actually she's still collaborating with us in different research projects, and also helping us in the organization of the Spanish bio schools. So thank you, Miriam. Thank you very much for being here today, and the floor is yours.
Okay, so this talk is called the GTC OSIRIS and the Calar-Alto CAFOS probe and first site releases with the VO. I would like with this talk to show you what we did, and instead of focusing on how we did this, I would like to tell you why. I mean, what and why will be my focus in this talk. Before starting, I would like to start telling you what we astronomers love to do, and when I say we, I say most of us. That is looking at the sky, observing the sky. And historically, we've done this with our own eyes, with instruments and telescopes. And many people, when you say that we are observing the stars, for example, picture something like this, but it has somehow changed. And it's something more similar to this. We acquire lots of astronomical data with observatories, with different instruments, and we have to deal with all this information, all this data. And in this talk, I will particularly talk about the images acquired with 2 different instruments at 2 different telescopes. I will name them here. So from now on, you will see GTC OSIRIS or CAFOS Calar-Alto, but I will not go into much detail in the instruments of the observatories. Just I will tell you that I'm talking about 2 different instruments at 2 different data releases because we did the same procedure for both of them. So all my talk will be referred to these 2 instruments. On one hand, we have the Gran Telescopio de Canarias observatory, the telescope, sorry, at the Roque de los Muchachos, and we have the Calar-Alto Observatory in Almería in Spain. So these will be our own 2 facilities, each with these differences in the configurations. And with these two telescopes, we can get images, spectra, and different data to analyze. I will focus only on images. And from these two telescopes, I recover these very nice images. And you can see the science that can be done with both of them is very wide. This will be nice, the nice pictures, what you would expect, but this is not what I will show from now on. So from each of these two telescopes, GTC and Calar-Alto, I will focus on the images taken with OSIRIS and CAFOS, as I told you, two different instruments with wide fields of view, and they share, in this case, that the images we used were taken in the optical G, R, I, and Z bands, and in different I do not recover the pointer. Well, it's okay. Different epochs, okay? As I said before, this is going to be the description on what we did and why we did this, that result in two different publications. So any particular detail you want to know about, you can go here. I address you to these two publications that were carried out, as Enrique said, as part of the virtual observatory group with different collaborators in each case. And the images we worked with were very different to those I showed you before. This is something more accurate as what we have when we observe with those two instruments and the images we selected from them. So I try to put always in your left-hand side the GTC images, and on the other side the Calar-Alto's ones. Very different. They have different fields of view, as I told you before. They have different characteristics, but these were our starting point. This is what we started with. So why we started creating a catalog and these first data releases. As you know, we astronomers like to observe the sky, and we take our, let's say, images. And for example, I myself as an observer, I make a proposal to a specific observatory with a specific instrument, and I've granted some time. So I have, for example, let's say May 22nd, I have my night to observe my particular region in the sky. So I have some images, a bunch of them, maybe, I don't know, 5, 10, 50, depending. So I have lots of images, and then what I do with those images, I process them, I analyze them, and I get my results, my scientific results. Then I publish my work in my favorite science journal, and that's it. That those images serve to my purpose, and I publish something with them. But the same that happened to me happened to many other people that asked for observing time, had their images, publish something, and again, and again, and again. So at the end, you have lots of images that all of them have been used for a specific scientific purpose, different in each case, with different observing conditions, different exposure times, different regions of the sky, and all of them, what happened with them once I perform my science? They go to the archive. And the archive, maybe you picture something like this. Like there's a place where you storage all of them and you can access them. Yes, but the archive could be something difficult to reach, or maybe you say, oh, I want to observe this star, this particular object, but I have to go to the archive, find where is it, and access it. And sometimes this is not that simple. So this is something that in the framework of the virtual observatory has been addressed. I will not talk too much about the virtual observatory. I think that in every talk we say something about it, but I will focus on this particular goal, which is to facilitate, to make easier the access to the astronomical archives, to data in astronomical archives. So in this case, I would like to show you, I don't know if you've been pointed out this keyword of the virtual observatory, which is FAIR. FAIR, what means that data must be findable. I should be able to easily find my data. And once I find my data, I should be able to easily access this data. So this is something that we address. In this case, the Spanish Virtual Observatory hosts different archives. If you go to the Spanish Virtual Observatory webpage, there is, I don't recover my, here. Yeah, thank you. There is this label archives, and in the archives, you can see a list of different archives. They serve as an astronomical data center, in particular for different telescopes. I will focus here, as I said, in Calar-Alto and GTC, and there are other astronomical data catalogs. I will talk about them later. Now I will focus on this part here, and in particular Calar-Alto and GTC. What does an astronomical data center does? Well, if it stores your data and it makes accessible to reach them. So if you go to each of these archives, you can see something like this with a description and with a search form, which is what we want to. I will show you how this is for the Calar-Alto archive. You have this form and you can look for particular objects, regions in the sky. Here maybe it's a little bit small, but you can see that you can also select the telescope or the instrument of your choice, and you can check if you have something already observed of your interest in the archive. Once you make a search, you get a list. Oh, okay, your target or your region or your particular instrument has observed in this, sorry, what happened here? Okay, has observed that particular date, particular filter. You can have here it is, the science data, calibration data, and all that I showed you. These are my images I observed, I worked with, then they become public. You can find them here. Immediately after observation, no. After observing, you have typically 1 year to exploit your images, and then they become public. So let's say if I have observing time today, you can see my data available here from 1 year now. So what were our goals here? I've told you that we have, for 5-10 years, lots of images acquired from different observers with different scientific goals. And what do we want to go here? If you already have access to those data, what's the point here? So what we wanted was to take all those images, homogeneously process them, so you can get directly the already reduced image, and on the other hand, extract the astrometric and photometric information of those images. So you can go to the calibrated images, or you can take the catalog in case you want to see if your target has been observed. But you can tell, okay, but I have already other large area surveys covering the entire sky, almost the entire sky, in these passbands. Why is this of interest? Well, maybe you want to check if you have a different observing epoch of observation of your target, or maybe you want to check different photometric, the different photometry in different bands. So later I will show you some examples of what can we do with this kind of high quality, ready to use data. Well, more or less is this here. We aimed at providing some high quality data that could be of use for the community and also can spare time. Because you can say, okay, I can go to my image, reduce it and process it. Yes, you can do that. But what we aim here is to do it in a more homogeneous way and just give you the data so you can do your science instead of taking time to process them and look for them which you can always do, of course. We try to make that simpler. Here is all the information you can check in the papers. This was not supposed to look like this, but it's okay. So what I will focus here is in this path here. So we have our raw images, we process them, we reduce them, we may perform the astrometric calibration, which means we convert our coordinates in pixels to celestial coordinates. And we make an image selection because we wanted high quality images to be used. Remember that each science case requires different observing conditions. So here we wanted to keep what we considered were best quality images to process them and extract the information. I would like you only to focus in these red numbers. We started with almost 30,000 images here and 42 here. We took 5 years from OSIRIS and 10 for CAFOS, so the difference is comprehensive. And we ended up with a very small, considerably smaller number of images. Why? Because we wanted to select not only the best quality images, but also we have to reject those with bad header information or different observing modes that we would not serve to our purposes. So still we have a significant number of images to process and finally provide to the community something like this. In this case, you can see the images is already processed and is clean. And here I try to play with the contrast so you can see these artifacts. This is a raw image. It was not already reduced. So what we provide, what you have in the archive ready to go is in principle here, but after we process them, you get the clean image with all this removed and already calibrated. We also have, I don't know if you can see them here, but there are lots of images with artifacts, saturated stars, weird things. So we had to do something with that. It's not just I detect something in my image and put in the catalog. We had to deal with these artifacts in some cases or these saturated stars because we didn't want to be. Sorry. So next we construct our catalog with point and extended sources. And you would say, what's point, why it's extended? Well, I found in the same image some examples. We call a point like something like star, something that looks like a point in our image, and extended something that may be elongated, but we did not attend to the nature of the object, only to the morphology. So I can tell, okay, I have this object that looks like it's an artifact, it's not a back pixel, it's something real, and I can classify it as point-like or extended. So when you use this catalog, you can say, you can classify or you can tell what kind of object are you looking for. Then we ended with thousands of sources in both cases. And I would like to point out that we have a number of sources and many more detections. What happens here? Okay, I imagine in my observing campaign, I observe the same region of the sky during the night in different bands, or maybe the same. But what I have is different images looking at the same region of the sky. So I have the same star observed several times. That's what we call detections. We have a number of sources. Many of them have been observed more than once, for sure. We have different detections and different epochs. More details, you can check them in the publications, but once we identify our sources and provide the coordinates of them, what would be the next step? We provide photometry for all of them, depending on the kind of source we have. We perform different, we follow different procedures, but we acquire very good very great accuracy in both of them. Here I just emphasize the years. We have here from 2009, from 2014. And in this case, it started more or less 2008 and 2019. July, this is 10 years and 5 years of observations that we used for creating these catalogs. That's it. No, that was not it, because of course we tried to do it well, and we needed to perform some quality tests, because you can tell me, okay, you did it all right, but how do I know that it is a high quality product, as you tell me? Well, we did some quality checks. This means if I already have a photometric survey with the same binds, I can check that my photometry is consistent with the photometry provided by, let's say, Sloan or Pan-STARRS. And I can also check if I have the same source observed several times. I can also check whether there is consistency among those measurements, or on the contrary, I have very different magnitudes for the same object. So we also check that there were no bias related to the position of the CCD or color terms, binning mode, and different things. So our final catalog, or maybe you thought that it covered large regions of the sky, and I can tell that yes and no. Here you have the different coverage of both catalogs, and you can say they are distributed almost everywhere, but they cover like 8 square degrees, 4 in this case, and they are randomly distributed. So this is not, we do not aim to provide a complete catalog covering all regions, because what we have here is what astronomers have been observing during these 5 to 10 years. So we only took the regions they have already observed and are already in the archive. And as you can see, we have images covering dusty regions or maybe more distant ones. This is something that we just have to deal with. And this is related to the exposure times. Of course, depending on what is my science case, I would need more or less observing time. For example, we have images with minutes of exposure. This means that perhaps in that image I have lots of saturated stars, but for my science that would be the correct thing, because maybe I have a very faint object and I need more exposure times. On the contrary, I have saturated stars that would not belong to my catalog because I don't use them. On the other hand, we have many images with low exposure times, which means that I will have bright stars and lose the faintest ones because I cannot reach them. So this is how our catalog, how do we describe our catalog in terms of exposure times and positions in the sky? And then you would say, okay, that's great. I have my catalog. I have my images. What can I do now? Well, in these works, in both of them, we carried out a few exercises to test and to show the capabilities of the catalog and the potential of recovering this information. So I will give you some ideas of what we did here. If our photometry is right, and I already tested it and it looks fine, I should be able to find specific type of objects. So we use all our photometry and make a selection, color cuts, looking for low mass stars. So I use G, R, I, and Z, and apply some color cuts, and then I complemented it with infrared photometry, and ended up with a sample of low mass stars that we already confirmed because we were able to estimate temperatures. And if we display them in an CM diagram, we can tell that our stars actually lie at the end of the HR diagram. So our photometry seems to work fine and to do science with it, because we were able to find more than 2,000 low mass stars in both cases. What else when you can do? I told you that we looked for consistency among the different measurements for the same star. So I have a star, and it has been observed 5 times, 10 times. And I checked that all my 10 measurements were consistent, and that's right, that's it. But we also have variable stars or variable objects. And this is what we check here. Okay, let's see if according to already known variable objects, let me check if I have those objects in my catalogs and how do they look. And this I show you in both cases, different colors, GRIZ bands, the magnitude of the star, all of them known variables, and what is the standard deviation of the measurements I got. So many of them, depending of course, it depends on how many times I observe it, but if we take all these stars that have been observed more than once, we recover some of these variables with larger standard deviations, which mean that we are providing photometry multi-epoch for these variable stars, and maybe that you find that is useful. We have more in the OSIRIS catalog. Well, we have many more stars in this one than in CAFOS, but still in CAFOS we were able to identify some variable stars with large spread in their photometry. Oh, this is one of my favorites. What could we also do with this archival data? In both cases, we run the SSOS pipeline developed by Max Malk. This is the solar system objects pipeline that aims at identifying solar system objects. So what happens here? If I observe during my night the same region of the sky with a cadence of minutes or hours, I am able to trace or to identify these solar system objects in my images that are characterized because they apparently move very fast. So this pipeline aims at checking for if an object at detection in my catalog is moving in time. I think that a great example would be this one on the right. These are 9 images going with time from left to right and from top to bottom, and you can see the blue dots with the blue circles which depict the linear trajectory of the asteroid in this case. So in these images, apart from the science I already performed because I was looking for my particular favorite object, happens to be that this asteroid was crossing by and we could identify them. Here you have the bottom, the numbers. We found in total of 5 comets in our images and an interesting number of main belt objects. All of these detections were sent to the Minor Planet Center, and this is very interesting because we already know many of these main belt objects, but if we are able to provide more positions in the sky covering more time, we can improve their orbits, or we can better them in case we don't have enough data. So more than 200 asteroids were detected in both sets of images, Calar-Alto and GTC. What else? Last example here. We identified some transient objects. What would be a transient object? This would be an object that in a short period of time changes brightness or position, as we saw for these asteroids. So in this example, we found gamma ray bursts that happen to be in our images. These are 3 GR and I images, and we identify 60 potential transients without information that would be interesting for a follow-up. among other that we already identified, that we already know. So with this exercise, we did not develop a complete science case, but we tell you, okay, you can do stuff with this. You can use this catalog and make science with them because we have already did or we addressed some of the science cases that can be performed with this. And all these, I told you that the reduced images can be found in the Calar-Alto and GTC archives, but our source and source catalogs can be found in the bottom part here. I told you that I will talk more about these data catalogs of the host of the Spanish Virtual Observatory. You can find GTC and CAFOS catalogs where the green arrows are. You can find them, and there are also other catalogs that do not are directly related with the archives shown on the top part. Let's say you perform your science and you get with a nice catalog of, I don't know, white dwarfs, and they have nothing to do with the previous catalog shown there, but you want them to be public and you want them to be accessible. You can always put them here. Actually, all these, all these catalogs belong to different surveys. So the different studies we've carried out and put them there for the community to use them. In all cases, you have this search form to look for a particular target, or you can download them all and use them for your purposes. I see I've run a lot. Okay, but you have them here. And then I would like to recover this keyword I told you about first, this FAIR keyword for the virtual observatory, where we said that data must be or should be findable. I think that we can check this. Data must be accessible. I think the archives already done that. You can also check that I didn't say anything about the eye of interoperable. Interoperability would be the use of different tools, different services that could connect with each other. You download your data and you need to carry out your work using different tools, and you want them to communicate among each other. You want to be able to use your images and afterwards move your images or your science to a different platform in an easy way. Sorry for that. So this is something that we've done here. We use different virtual observatory tools and services. These are for them. And in all cases, we were able to, for example, I used Aladdin to charge my image or to look for my image. And then I extract the catalog, and then I move my catalog directly to TopCat, or do something with stills, or make spectral energy distribution with VOSA, and the output just move it to TopCat. So in all cases, these, I would say 3 applications plus stills were open in my desktop at all time, and I could move my data from one to another. So that would be something interoperable, that easy the way you work with them. And regarding the R reusable, I think that we can also check this part, because we took those images that were already in the archive for you to use them, but we go a step further and process them, create this catalog, and show you what different kind of science you can do, besides the one that put them in the archive in the first place. So I think that we can check all the 4 of them and encourage you to reuse your data always. I think that this is a fantastic way to really make science and exploit our data, because it's very common that we take I'm talking about images, but I could say the same the same for spectra or other kind of data. And once we do the science we want them to do, we forget about them. And this is a very nice way to encourage you to reuse them and make them public so other scientists could take them and keep getting knowledge from them. So I would finish here. Sorry, it was a bit fast, but with this, I think I will finish my talk for today. If you have any questions or comments.
Well, fantastic. Thank you very much, Miriam, for that really interesting talk. It's great to sort of hear the processes that kind of go into these, you know, fantastic data archives. So if we've got any questions here in the room or on Zoom, you can raise your hand manually, or you can do it on Zoom, and we'll get to you. So I'll take the chair's privilege and ask the first question to get what going. So with the sort of the gamma ray burst stuff, that sounds super interesting. So you found a small number of those. I forget how many it was, but were you able to sort of determine sort of redshifts for these gamma ray bursts?
No, in this case we only chase for these examples sort of the kind of sources that could be found here, that could be detected. So we checked, okay, what kind of transients do we have here? Oh, I found a gamma ray burst. I just tell you that I have it, but we didn't go deeper on each of these objects.
Okay, it's really interesting. How long after the event? How long after the transient did you have the data for the?
We did not explore that.
Yeah. Okay.
Yes, because in these works we tell the details on how we did that, and then we just put some examples sort of what can be done. So if you're interested, just have a look at them.
Sounds good. So any questions in the room here? There's a microphone winging its way across to you now.
Thank you. Thanks so much for the talk. I was wondering whether you have any plans in the future to expand this kind of work to other observatories. I'm thinking about radio observatories like the Observatorio de Lleves, for instance.
As far as I can tell, we don't, but I will go back to Zoom because maybe Enrique has more information. But for now, I don't think we have planned anything like that. Of course, also the latest images we have here are from 2014, I guess, no, 2019. And still we have more years from that, and we don't plan to continue it. Yeah. Also, we've asked to do the same for spectra, but you need more human power, I think, here. That would be interesting in any case to expand to other observatories and instruments, yes.
Any more questions here in the room? Unless Enrique, you want to comment on what Miriam just mentioned there?
Yes, just to complement what Miriam is saying. Yes, we are in contact with the Lleves Observatory because they are interested. In fact, they are building the archive for the 40-meter telescope. And the idea in principle, the archive will be hosted under the Lleves or OAM premises, so they will be in charge of developing the archive. But they have contacted us as to know more about how to develop the archive under the virtual observatory framework. So the answer is yes. There will be an archive for the Lleves observations, and eventually it will be virtual observatory compliant.
Yeah, that's really interesting. If you switch back to your slides, then we don't have to. So any further questions here in the room, or on Zoom? If any brave participant wants to raise the hand on Zoom. I was sort of going to ask about the sort of solar system objects that you guys found. So were these? So this was a sort of combination of new detections and things that were already known. Is that correct? Or were they all new detections?
Yes, yes. I mean, I assume that we are not detecting anything really new because you already have these large area surveys that go deep enough and cover large areas of the sky. But particularly these transient objects, maybe that specific epoch, you don't have these other observations. And I think that here it remains the power of them, different epochs of a star or an object that you already know, and you want to cover in that period. Yeah, but as I tell, I mean, we checked these transient objects, for example, and we, of course, we look if we already have information about them, because this would say, okay, this is not a bad pixel that I've lost in my catalog. So we identified already known, and we found out there are these 60 others that could be, and we propose them for a follow-up. Of course, anyone can take the lead on this and check whether these are really new objects that have not been classified or identified by us in the search we did. As I said, this was not a thoughtful search, but just to double check and provide new possibilities to carry out here.
Yeah, that sounds interesting. Do you need sort of spectroscopic observations for that, or is it just okay? Yeah, that's the real
Yes, of course. Here you have the hint, and you then explore it beyond if you want.
Brilliant. So any further questions in the room or on Zoom? Well, if not, let's thank Miriam again.
Can plug this up.